What's poppin', dogs? Mr. Allen here, solving for some missing angles in right triangles in this video, which means we're going to have to bust out some trigonometry and, of course, your graphing calculator for this bad boy. All right, so first thing here, I'm going to write down SOHCAHTOA, right? It's sine, which is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, right? We got that acronym to help us remember that, and that's to help us set up our trig equations here with the proper trig function. All right, so whichever angle I'm looking for is going to dictate what my opposite and my adjacent sides are going to be. All right, my hypotenuse is always across from the right angle. So let me just jot that down right now. This guy, hypotenuse, right? It's the longest side. It's hyped to be the longest side. It's across from the right angle, the biggest angle. It's going to have the biggest side. Now, whichever angle we're going to solve for first is going to dictate my opposite and my adjacent. I'll go with my angle A here first, because it's first alphabetically. I don't know. I guess so. Yeah, sure. And that's going to be across from the 14-inch side. So this is my opposite side. This guy would then be my adjacent. But really, my adjacent doesn't matter in this situation because I only know information about my opposite and my hypotenuse. So to set this one up, I'm going to use sine. Opposite, hypotenuse, sine's the move. So I'll write down sine inverse of my opposite over my hypotenuse, and I can just plug that into my calculator. That's going to equal A right over here, angle A. Boom, that's it. That's wonderful. All right, now people are like, wait, what? Inverse? I'm going to show you guys the algebra here in just a sec, but sine inverse, anytime we're solving for an angle, I'm going to be using inverse trig. And now we do have to make sure, okay, that your calculator here is in degree mode, because if it's not in degree mode, you're going to get some crazy answers. So if you hit mode, notice that mine, 2 down to the right, or hit arrow down twice and to the right once, it's in degree mode. If your calculator ever powers off, restarts, new batteries, whatever it may be, it's going to default to radian mode. So make sure that you put that thing back into degree mode anytime you're about to get tricky with it, and we're asked for answers in degrees, okay? Radians have their place in other parts of mathematics, but likely you're in geometry or maybe algebra 2 right now with some trig. Degrees are what you're going to be using, all right? So second sine would be sine inverse of 14 over 23, all right? And I'm going to get 37.495. It says 2 decimal places. That 9's going to get rounded up by that 5. This always freaked me out back in the day. I'm like, ooh, how am I going to round that? Well, the measure of angle A is going to be 37.50 or 0.5 degrees. That is going to be 1 decimal place. Really, it's the 2 decimal places ends up being 0.5 because the 9 gets rounded up and boosts it up, okay? So there we go. 37.5 degrees, 37.50 if you want. Either way is cool. Now, do I have to keep on getting tricky with it to figure out what angle B is? No, right? Because all of my angles in a triangle add up to 180 degrees. 90 was already taken care of here with angle C. So really it's these two angles add up to 90 degrees, the other half of the triangle. So 90 minus that 37.495, or I can just do 90 minus 37.5, which is going to give me 52.5. Okay, so the measure of angle B equals 52.5 degrees. So again, in this case, only 1 decimal place just because of how the rounding occurred. I should circle this, and I should also make these kind of like squiggly equals because it's approximately that. We did do some, sorry, hit the mic. I did do some rounding there. Boom. Okay, cool. Awesome. Fantastic. Now, I did say I was going to show you guys algebraically like what's happening here. So I'm going to do that over here. Move the calculator out of the way here in a second if it does get in the way. But here's what's happening. Okay, when I'm solving for angle A, my normal setup would be the sine of angle A equals my opposite, which is 14 over 23. And now sometimes what they'll actually ask you for is like, what is sine of A? It's 14 over 23. So sine of A is just a ratio. But now, if I want to solve for A, right, if I want to get A by itself, get that angle, I have to undo sine. How do I undo sine? It's not sine times A, it's sine of A. It's a function. And the way that we undo a function would be with an inverse function. So I take the sine inverse on this side, which cancels out the sine, leaving me with just A. And then if I do that to this side, I got to do sine inverse on this side as well. And now I have sine inverse of 14 over 23. Plug that bad boy in my calculator, get my angle measure. All right, but that's a lot of different, little bit of algebra that's honestly, in my opinion, kind of unnecessary because it's like, I know if I'm solving for the angle, I'm going to use the inverse. If I'm solving for a side, I'm going to use regular trig. And that's something that I commit to memory and I have my students work on as well, is that, hey, angles, use inverse, sides, use regular old trig. Cool? Awesome. I would jot that down in your notebook. Smart idea. Okay. Last one here. We've got both angles on this one. So now we're solving for A and B again over here. It doesn't really matter which one we start with. I will still start just with A alphabetically. Boom. So I'm going to label my triangle accordingly. Opposite the A is the 12. And next to it, adjacent, is this guy right here. Because I know that this is my hypotenuse. It's always across from the right angle. Lovely, lovely, awesome. Okay. So I've got opposite and adjacent. Which trig function should I use? Tangent. Yes. If you said tangent, you were absolutely correct. We're going to do the tangent inverse of my opposite, which is 12, over my adjacent, which is 9. Any prediction as to which of these two angles is going to be larger than the other? Across from the larger side is going to be the larger angle. Across from the smaller side is going to be the smaller angle. So A should end up being a larger angle. And this is going to equal angle A. I'll just put A right there. Let's plug that bad boy into the calculator. Second tangent of 12 over 9. And I get 53.13. Sounds like it's going to be the bigger one because these two have to add up to 90 degrees, right? And if this is bigger than 45, it's already bigger than half of that. So anyways, measure of angle A equals 53.13 degrees. So it's a weird 3. So, oops, squiggly equals. I would not mark you off if you didn't put the squiggly equals. I'm just being bougie with math. When I do the squiggly equals, so I'm like, oh, it's rounded, you know? All right. And then how do we get the measure of angle B? Well, I could do tangent of this over that, or I could just subtract from 90. Either way you slice it, it's up to you. I often do 90 minus just because I know it's the complement. Reminds me that it's the complement. They add up to 90. I start thinking about all the different features of triangles that way. In any event, measure of angle B is equal to 36.87. 36.87 degrees. Now, one thing that I do always like is make sure that these guys right here add up to an even degree, right? Because these two will add up to 90 degrees. Sometimes the rounding is actually a little bit weird, and you end up losing like 100 splits or something like that. But anyways, we'll cross that bridge when we get there another time. But one last thing before we go here. If I do tangent inverse of 9 over 12, will I get this 36.87? Boom! Same exact thing. Whatever you want to do, however you want to slice it. You could even done that over here. We could have done cosine because this is adjacent from B. That's adjacent over hypotenuse. Check it out. Cosine inverse of 14 over 23, 52.5. Look at that. Different math. Still checks out because it's the math. I don't know what I was about to say there. But anyways, the math works. You can do it multiple ways, which is kind of cool. So hope that helps there, guys. I don't know what I'm saying. Anyways, you know what? That's it. Have a good day.